So in this quadratic modeling problem, we're going to model a very typical, I'm going to say PSAT question. And so it seems very easy to start off with. You know, if you look at this first part of the sentence, what you have is two numbers whose sum is 24. I feel like that's a pretty easy thing for most students to do because of Algebra 1, right? So two numbers in math is typically represented by X and Y. And then their sum means plus, and then is means equals. And so when the first question says, could you set up a system of equations, it's simply X plus Y is equal to 24. Now, the problem is that students will join the second part of the sentence right here. And this right here is actually a separate equation. The separate equation here is that you have a product that is as large as possible. And what throws students off all the time in this type of problem is say, I know what product means. Product means multiplication. And they come down here and they say X times Y. And then what does it equal? It doesn't say that it equals anything. So kids will set it equal to 24 or something. It actually equals to the function called product because you're trying to maximize the product, which again is going to mean that we're going to use a vertex, which we'll get to in a couple of moments. Well, this sets up a system. And in order to solve the system, what it says to do here, in order to solve this system, what we have to do is we have to solve this system like we would solve any system from Algebra 1 or 2. We need to plug one equation into the other. It would be very easy to solve this for y and get negative x plus 24. You could solve it for x or y, but most students are used to solving it for y. And then what you're going to do is you're going to plug that back into here. All right, so that's going to look like this when I do that. It's going to be x times what y is solved for is equal to p, and y was solved for negative x plus 24. So if I need to put this in standard form and distribute it, I would get p of x, I'm just writing the p on the left side like we'd like to have it, is equal to negative x squared plus 24x. Notice that that now says p of x. Over here, I just left it p because it was p of x and y. I mean, I guess you really could write it like that. Maybe that would help, say p of x and y. But over here, now I have p in terms of x only, which is going to allow me to solve it. I couldn't solve this with two variables. So two things going on here. This is what we call formally as a factored form. And this would be really great for finding x-intercepts, which we'll talk about in another problem. But the standard form is really important for finding vertexes. And notice that it now wants me to find, in this problem, it wants me to find the maximum product. So we solved the system to find the maximum product. We're now going to employ this, which we looked at our previous example, but if you're just seeing this one for the first time, to find the maximum, you're finding the vertex. And the vertex is minus b over 2a, and then f of minus b over 2a. And please keep in mind that this is what this is saying. This is my input. My output is to plug my input in. But it's really important, as I've been saying the whole time, it's very important to understand what inputs and outputs are, especially in a problem like this that's kind of vague. Two numbers, what does two numbers mean? So my input in this function, remember, we're trying to look at this function here now. My input will be x and my output will be the product. It's really important to understand that because you never see y in here. And we'll talk about how to get y in a couple of moments. So to do minus b over 2a, remember, it's just the quadratic equation. So a is here, b is here, and c, if I need it, is 0. So it'll be minus 24 divided by 2 times negative 1. Luckily, I don't even need Desmos for that. Most people, I think, could see that that is equal to 12. So the x value, to answer the question, what numbers do I need? So I'll highlight that in a different color. The numbers that I'm looking for, I know one of them right now, right? So let me just label that real quick, keep everything straight. The numbers we need, I know that x is 12. Currently, I don't know what y is, okay? Now, if I go back into Desmos to figure out the next thing, you might still have some stuff from a previous problem. To clear it, just enter, and it'll say, do you want to reload? And that gets rid of everything, resets the axis. We don't need the axis right now, so I'm making it a little smaller. So in this problem, we need to find f of that, and the easiest way to do that is to just plug it in like I showed you. So we have negative x squared, and here we're going to put a 12, We're going to put a square here. You can either hit the caret button or you can use this. And then you're going to say plus 24 times 12. And that number, 144, right? So just a reminder how I got that by plugging it into here. And then it gave me the answer 144 in Desmos. That number is the product. So that's actually an answer to a different question, which I actually have right here, right? So that's the answer to this question. The maximum product is 144. So this is the question students ask me all the time. They say, Mr. King, how do I find the other number? Well, the other number is actually found right here. If I take 12 and plug it into here, it will output the other number. So the other number would be negative 12 plus 24. That will give me y. And so the other number is 12. And it all kind of makes sense now, because what is 12 times 12? 144. But the y value is not in this system, because the system is in terms of x when it originally was in terms of x, y. So that takes a minute to understand, but hopefully that will sink in and make sense. Okay, so the next thing we need to do is we now have a different problem. So it says, then use the same system to find two numbers whose product would be, who would produce a product of 20, meaning it wants me to use the system of x plus y equals 24. And you can see I wrote it out a little bit more explicitly here. So what two numbers have a sum of 24 and a product of 20? And then instead of saying x times y equals p, it wants me to say 20. So you're going to do it the same way. This is a separate type of SAT question here, where they actually tell you that product. So you get negative x plus 24, and then you're going to plug that into here. But the difference is it's going to make a quadratic equation that actually has an answer, which is 20. And that means we do something else, basically. So when there's no answer, you're going to use the vertex when it asks for a maximum, for instance. But in this case, I have x squared, so negative x squared plus 24x equals 20. And that is a quadratic equation. It's supposed to be an x right here. The problem is that if I don't remember, I might plug stuff in wrong. So the quadratic equation, we're going to want to solve it for 0. So I'm going to actually add x squared and then subtract 24x to both sides. I like to keep the lead coefficient positive, though it's not required when you're going to use Desmos. It's just a good habit to be in. And so that's going to come out to, we'll get to that in a little bit. That's going to come out to 0 is equal to x squared minus 24x plus 20. And that's going to give us an A, a B, and a C, right? I have an A here, a B here, and a C here. And I'm going to go into Desmos now and solve it. So just to recap, why am I using the quadratic formula here? Because I have something to solve. Up here, it asks for a maximum. Maximum means vertex. Just a little recap to make sure we understand what we're doing. So I'm going to come in here and I'm going to plug in, just like we did last time, A equals 1, as you can see right here, A equals 1. And okay, so A equals 1, hit enter, B equals negative 24, and C equals 20. And then I'm going to type in the quadratic equation. Minus B plus square root is in the keyboard. So if you don't have it, you got to toggle it up there. Then you have B squared minus 4AC. You're going to highlight the whole thing and then divide by 2A. And the first answer is 23. And remember what I said, there's no plus or minus in the keyboard. You can't find it. So to do the minus, you just put the minus here. And so those are my two answers, which I have right here for you. Okay. And so the interesting thing is we'll check the system in a minute, is how do I find y? Well, it's the same problem. These numbers are both x's. So if my answer is x equals 23.136, if I want to find y, I have to go back just like I did and use y. Y is negative x plus 24. So y will be negative that number plus 24. Give me 1 second, 23.36. And if you type that in Desmos, you kind of get a little bit of a surprise. So let's see what happens when I plug that into Desmos. So when I plug that into Desmos, I'm going to just take this part right here. You can just highlight the whole thing in Desmos and hit Control-C and paste it. So I have negative that number and then plus 24. And you see that I actually get the other number that the quadratic equation spit out. The reason that is because both of our if we go back and look at our equations, there's a 1 in front of these two things. Had I said something like one number is 3 times the other, find the sum, that is 24, it would probably change it so you actually have to plug it in. So what do I mean by check the system? So what's interesting about this is if I were to actually take these two answers, because remember the answer that we have is this is x, right? This is x, and this is y. It actually checks out beautifully when I put it in Desmos. And to save a little time here, you can see that I added them together and got 24, and then I multiplied them together and got 20, which is what it says. I should add them to get 20 and add them to get 24 and multiply them to get 20. And the way I did that was I simply went into Desmos and I just copied the number, which is really cool, right? So I just take this, Control C, put plus, and then here I take this number, Control C, and put there. Hey, look, the sum is 24, and then I can copy this whole thing and then change that addition sign to a multiplication sign, and you can see that I got 20. So little recap, this was kind of 2 problems in one. One was a maximization of a sum and a product. This could be a difference in a quotient, by the way. This could be any combination of operations. Maximum is to find a vertex. The maximum is a little harder because you have to set it equal to P and then solve for P, and then do it in terms of one number, and then find the product, realizing that that product is really not y, right? So this is x, but that's not y. You find y by going back to here, which makes a little more sense if I actually set it equal to a number, but sometimes I like to do the hard one before I do the easy one to help you understand the difference. So when I actually set it equal to a number, I would use the quadratic formula. All right, I hope that helps, and I hope it was insightful in terms of why we're learning these application problems.